All right. So for a change, what I'm going to do is instead of pre-writing all the problems and explaining you for saving time, I'm just going to randomly pick few problems which I think are very important and which are very tricky, and I'll solve it in front of you right live so that you can see how I'm thinking about it when it comes in the exam and what kind of logic I'm applying to break the problem into simpler formats. So that will kind of give you idea kind of when the problem comes in the exam hall. It will be kind of a real time scenario or simulation of how to solve that. And I'll do it for some of the random problems which are very difficult and tricky or important or where I would want your attention. And for rest of the things which are pretty straightforward or very repetitive, I'll just continue with the old format of quickly pre-writing it and just walking you through so that most of the times it's very self-explanatory. So in the last video, we learned about the type 4 multiple angles. We learned the concepts. And as I said, there are only a couple of problems that come in exam, at least in the last 4 question papers for last 2 years. And I'll solve those in the traditional format of pre-writing it. But for a change, let me just solve one of the problems that came in exam real time, and then you can see how I'm thinking about it. So let's pick up this problem which came in the summer 2018 for 4 marks, where it's asking to prove that sine 4 theta plus 2 theta divided by 1 cos 2 theta 1 plus cos 2 theta plus cos 4 theta is equal to tan theta. And there will be variations of this problem. This is very important because I think this problem will definitely come in the exam, some sort of these problems, or more than likely this, and there are only 1 or 2 variations. This is the closest variation that I think is very relevant that I picked up 10 years back, that came in September 2011, where it talks about this equation on the left side and the right side. So this is just for reference. I'll solve this problem also kind of at the end of this video and quickly walk you through. But let's solve this problem real time and see how I'm thinking about it and how we should break it down. So let's say you're sitting in the examination hall, you're writing the paper, and you're getting this problem, and now there are too much things going on in your head, and how do I break it? So the few things that will quickly come to your mind is, you know for sure that this is something to do with type 4 multiple angle, because you can see that it's 4 theta and 2 theta, 2 theta, 4 theta. It's like multiple angles written all over it. So like I said, most of the times in trigonometry, the hint will be given in the question itself. And secondly, it's prove that something is equal to something. So you can never go wrong, because unless you get the right hand side from the left hand side, you can keep on going. So that's a good thing. So I know that it's a multiple angle formula. I need to do something about multiple angle. And the other thing, that pattern that I always told you is, especially when it's a double angle formula, you'll always see that the left side or one of the sides is always double and the other side is half. So here also, if you see, there is 4 theta given all over here, and on the right side it's 2 theta. Over here also, if you see, it's 8 theta here and 4 theta here. So not necessarily on the left side or right side. Let's assume that the overall problem will be a mix of some trigonometric functions which has it's a double angle, and somewhere it will ask you to prove, or it will also, there will be also in the mix the half angle of that, and that's kind of the biggest clue that how you need to solve. And especially based on the left and right side, you need to see how it's going to be working out. So let's focus on this problem at hand for now. So if you see here, I know on the left side I have 4 theta, on the right side I have tan 2 theta. So okay, so I know for sure that I need to apply, let's say I'm just going to write it here. Okay, I need to apply the first check mark. I need to apply multiple angle. I know that. Okay, I got that correctly. Okay, and I know something is going on here. And the other thing I notice is, okay, let me take a pause before I solve the problem. Let me see what the question is saying. Okay, on the left side, they're talking about 4 theta. There's angle 4 theta and there's angle 2 theta. On the right side, they are talking about tan 2 theta. So I know that on the left side the angle is double and the right side is getting half. And tan 2 theta, always whenever you prove any angle, right, left hand side is equal to right hand side, always try to simplify 1 or 2 levels below, because there could be different ways you can express this tan 2 theta, because I'm not sure which one I'm going to apply. For example, one way of representing this tan theta is sine 2 theta by cos 2 theta, right? That's one way of representing that. And the other way of reading is, since I know it's a multiple angle, so do I need to apply tan 2 theta is equal to the formula for the tan theta, like for example 2 tan theta upon 1 minus tan square theta. Do I need to apply that we need to check? Okay, so now I don't know which one of this I'm going to apply. Okay, but for the sake of simplicity, I'm just writing that. Okay, the only thing that I know about tan 2 theta is either this number 1 or number 2. Let me figure out. So as long as the left hand side I get into some of this shape, I know that I can prove that it's equal to tan theta. So let's park it for now. Let's move back to the left hand side and let's start breaking down the problem. So I'm going to take the left side here. So the left side over here, okay. And I know that straight off the bat that there is sine 4 theta, and I know that sine 4 theta is a multiple angle. And what is the angle? What is the formula I'm going to apply? I know that sine of 2a is equal to 2 sine a cos a. I'm going to just highlight it in different color so that you know the formulas. Okay, this is the formula, right? And so in this case, let me take a different color. Okay, in this case, it's given us 4 theta. It's twice. That means it's like something like this: sine of 2. Okay, sorry about that. Sine of 2 into 2 theta, right? That's how it's like that. That's all this 4 theta all about. So this is asking that format. So if I have to expand in that format, it will be 2 sine. In this case, a is 2 theta, and cos of a is again cos of 2 theta. So I know this formula can be written like this. So what happens is sine of 4 theta becomes, using this formula, 2 sine of 2 theta minus cos of 2 theta. Okay, that's how we get that. Okay, and then we need to see what else I can simplify. So on the right hand side, like I said, on the right hand side, I need to either come into this format or this format. So if I'm breaking down over here, so far it looks like I don't have to take option number 2 because I don't see any tan complications, and I don't want to introduce tan square. So maybe this might work because on the left hand side, the simplification looks like I'm kind of getting some of the things that I want to see on the right hand side, like a 2 theta or cos 2 theta over here. I'm able to see it over here. Okay, so I'm getting that. So let's break down the next formula. And also I know, okay, let's try to substitute what we learned here into this formula. Okay, so if I keep on building this, let me just scroll it down a bit. Okay, that's good. So if I keep on building this, so what will happen is left hand side of the equation will be 2 of sine 2 theta cos 2 theta plus, from the given equation, I know that sine 2 theta is there. I'm going to write it as it is, no change for now, divided by, I'm going to apply 1 cos 2 theta, and I also have cos 4 theta here, so I need to write the formula for that also. I missed it earlier, sorry about that. So cos of 4 theta is equal to, if I apply the same way that I'm going to apply, is equal to cos of 2 into 2 theta. And if I apply the formula, you remember I have told you one of the variations of cos, right? So always remember that you have to apply the variations of cos, and you have to see which variation you need to apply among the 2 or 3 variations. In this case, if you see on the right hand side, I want something in this pattern, sine upon cos, right? I don't want the tan, so I don't have to worry about cos in terms of tan. And since in the denominator I want to use cos, more than likely what I should do is I should express this function in terms of cos, because I don't want to bring sine, otherwise it will become sine upon sine, and again you have to do resubstitution. So that's the most important thing. That's how you should think about that. Which one should I apply whenever I need to pick up whenever I have a choice. And that's the reason I told you that this particular, the cos variation is always important. It's not difficult, but you always need to remember that you need to pick up the variation which will support you to prove the point on the right hand side. Like I said, in this case, I need to, at the bottom, I would like to have some cos function. So I'm going to express this cos in terms of cos. So if based on, if you go and check out the previous video or the previous notes, you will know that expressing this function in terms of cos, I can use this equation like cos 2a is equal to 2 cos square a minus 1, right? And where a is your, this is your a, right? Let me write it down here. Okay, this is your a, right? So with that, if I keep on continuing, so cos 4 theta will be 2 cos square, my a is 2 theta, so 2 theta minus 1. Okay, so that part I can write down here, right, over here, because I need to substitute for cos 4 theta. Cos 4 theta is equal to 2 cos square 2 theta minus 1. And if you see here, somewhere I'm trying to get it closer to the right hand side. So every now and then I'll always check whether I'm getting closer to the right hand side. If it's not, then maybe I need to do some different substitution. In the exam, normally you would not get that much time to think, but if you practice and if you remember the few tricks, because there are not too many variations, you'll know that, okay, as long as I'm getting my left hand side substitution to the closer to the right hand side pattern, it's good, because I'm getting sine over cos here, and all of this looks like sine over cos here. Maybe I'll be able to simplify that. So let's keep going. So if I simplify this, if you see here, let's on the top I can take sine 2 theta, this part and this part common. At the bottom I can take this part and this part common. So let's take the common things out. So I can take 2 sorry, not 2 will not be common, sorry about that. So I'll take sine 2 theta as common, and the bracket I'll put the remaining things, which is 2 cos 2 theta plus this will be 1, because when I multiply that it should give the same answer as the numerator. And similarly at the bottom also, if you remember here, this 1 will get cancelled with this 1. I don't have to worry about that. And if I take the common parameters, cos 2 theta is the common parameter, and if I substitute, it will give me 1 plus 2 cos theta. So that if you multiply that, it gives the denominator. So if you see here, this portion within the brackets, right, gets cancelled, and what remains is sine 2 theta upon cos 2 theta, that equals to tan 2 theta, and that's the pretty much the answer that you want, because that is equal to your right hand side, right? This is what you wanted on the exam, right? Okay, so that's how I solve this problem. So the key takeaway is, like, just think about the problem, make sure that whatever you're substituting on the left hand side, it should match the right hand side, and hence this particular thing over here, you don't have to apply this formula, because if you apply this formula, the right hand side will be completely in terms of tan, whereas the left hand side will be completely in terms of sine and cos, and you don't want that. Then you might have to convert this into tans. So always, whenever you have two options, just pause, take a breath, see what's going on, and at every step check if your left hand side is anyway approaching to the right hand side. Write down the formulas, and you'll be able to take it from there. So the next problem is this one, that I'll just pre-write it and come back in the video and explain it, and I'll go over that very fast, but it will be the same thought process where you have 8 theta here, you have 4 theta here, and at the denominator you have 2 theta. So somehow I need to convert the left hand side into functions of 2 theta. The numerator I'll keep into 8 theta and then continue with that. So we'll talk about that when we come to the problem. So this is how you kind of solve this problem. So this is kind of the detailed explanation of how I would be thinking when I get the problem. Whereas if you go through the other videos, I must have just pre-solved it and I would have explained that. Hopefully this helps. I'll see you in the next video.